Okay, this is our notes on simplifying radicals. I've got some words up here, then we're going to do one example, actually a couple examples. So the idea basically is if we want to take radicals, we want to move anything that we can from the inside of the radical to the outside of the radical. We want to leave as little behind on the inside of the radical as possible. To do this, we're going to start by breaking down the inside of the radical into its smallest possible factors. We'll look at any numbers and we'll do a factor tree on that to break it down to its prime factors. A lot of times I'm actually going to write out, if we've got, for example, x to the third, I'll write out x times x times x. Once we've got everything broken down as small as we can get it, we're going to look for groups of like factors. And the size of the group is determined by the root of the radical. So if we're talking about a square root, that would be a radical index of 2. If we're talking about a cube root, it would be a radical index of 3. If we're talking about a fifth root, that's a radical index of 5. And we would be looking for a group size to match that radical index. Any groups that we can find, we're going to be able to move those groups to the outside of the radical. Now for each group, you only get to bring one of that factor onto the outside. But the entire group would be eliminated on the inside. Anything that you pull to the outside of a radical is going to multiply with everything else that's already out there, including other stuff that you brought to the outside and any other factors that were on the outside of the radical to begin with. Now you're going to see sometimes negatives on the insides of radicals. And what you do with that depends on whether it's an even root or an odd root. So square roots would be even roots, and fourth roots and sixth roots and so on. And if you see a negative appear on the inside of an even root, then you're going to end up with an I appearing on the outside. However, a negative root inside of an odd root, like a cube root or a fifth root or a seventh root, you can just bring those negatives right onto the outside. If there's stuff already outside, then just multiply what's out there by a negative 1. Okay, we're going to work through a few examples here. We're going to start with some radicals that just have numbers in them. So the first one I'm using the number 20. So I'm going to start with a factor tree. I want to try and break 20 into its smallest possible pieces. 20 we can write as 10 times 2. 2 is as small as it can go. It's a prime number. 10 we can do 2 times 5. And those are both primes as well. So I could rewrite radical 20 as the square root of 2 times 2 times 5. If you try that in your calculator, 2 times 2 times 5 is 20. And those are the prime factors of 20. Now, since this is a square root, note that there is no index written here, which means we assume that it is a square root. Then we're looking for groups of 2. And I do have a couple of 2's here. So we're going to be able to bring that group to the outside. When it moves to the outside, you're only going to get a single 2 that's going to come out here. So for each group, you get one factor that comes to the outside. There's a 5 left on the inside, and it's going to stay on the inside. So our final answer here is going to be 2 radical 5. All right, next problem, we're looking at 48, a little bigger number, so I'm going to start by splitting it up with a factor tree. So let's do a factor tree off to the side here. We got 48. And we'll start splitting that up. So 48, we can get that from multiplying, 4 times 12. 4 is 2 times 2. 12 is 3 times 4. 4, 2 times 2. So we've split that up into its prime factors at this point. So let's rewrite 48 as, what do we got there? 4 2's. 2 times 2 times 2 times 2 times, and then there's a 3 in there as well. So 48 as in its prime factored form would be 2 times 2 times 2 times 3. Times 2. I think I missed a 2. Whatever. All right, 4 2's and a 3. So we got to find groups of, again, 2, because our index would be 2 here. There's a group of 2's and a second group of 2's. So this time we have 2 groups that are going to be coming out in front. When we bring stuff out in front, remember, you only get one that comes out for each group. So I've got 1, 2, and another 2. And when you've got more than one thing coming out, those things are going to get multiplied together. The 3 was not able to group up, so it's going to be left behind in there. And we're going to want to write our final answer here. 2 times 2 on the outside, we've got a 4 on the outside. When we multiply those together, 4 radical 3. All right, the next one is a cube root, which means we'll be looking for groups of 3. I also noticed that there is a negative on the inside. Now, we're going to go ahead and just deal with that right now. A negative on the inside can be pulled to the outside. Okay, because this is an odd number group, we can just pull that negative to the outside. Go ahead and split up this 178 and see what we can get out of that. That's 2 times 64. 64 is 8 times 8. And 8 is not prime, so I should not circle it. 8 is 2 times 4. 2 times 4, and then 4s can be split into 2s. All right, so our primes are a whole bunch of 2s. 1, 2, 3, 4, 5, 6, 7 2s. So inside here, what we've actually got going on are 7 2s. Let's go ahead and write this out. 128 is 7 2s. Now I need to find groups of 3 inside of here because my index is 3. So there's 1 group, 2 groups, we got something left behind there. We're going to have this 2 left behind. So when we write this, we're going to have our negative out in front. We're bringing 2 groups of 2s out, and there's going to be a single 2 left on the inside here. We'll go ahead and multiply everything out. We're going to end up with a negative 4 on the outside. Cube root of 2 is what's left over. That's going to be our final answer. Let's move on to some examples that have some variables in them as well. This is going to be pretty much the same thing. It's just, actually, it's a little bit easier, I think, because we don't have to rely so much on factor trees. We're still going to want to take the number that we see in here, this 80, and do a factor tree on it. So let me just do that really quickly. 10 times 8, 2 times 5, 2 times 4, 2 times 2. So let me go ahead and rewrite this. I'm going to leave this negative 3 on the outside. We've got a square root. We've got 1, 2, 3, 4 2s. And a 5. And let's look at the variables. We've got u squared, which is u times u. And we've got a v in here. So altogether, that's what we got. Because this is a square root, we're going to be looking for groups of 2s. So I've got a pair here, and a pair here, and a pair of u's here. So for each of those things, we're going to be able to pull some stuff out into the front. Now the negative 3 is going to stay. It's going to multiply by anything else that we pull out the front. The 5 and the v are going to have to stay inside because we weren't able to group them up. But we do have a 2, another 2, and a u coming out. For our final answer, we'll go ahead and multiply this out. Negative 3 times 2 times 2 is going to give us negative 12. We've got a u out in front and square root of 5v left behind inside. And for our final example here, we are going to simplify this time. We're taking a cube root, and we're going to need to do a factor tree on 24 as well. This should be relatively quick though. 4 times 6, 4 is 2 times 2, 6 is 2 times 3. So prime factorization, we've got 3 2s and a 3. So let's go ahead and rewrite this. The 3 is going to stay up front. Actually, let's go ahead and bring that negative out, so that'll make it a negative 3. There is a negative here in our original problem. 24 I'm going to rewrite as 2 times 2 times 2 times 3. We've got m to the 5, so 5 m's. And excuse me for doing this, but I got to move down to the next line. We've got also 3 n's going on in here. All right, we've got a cube root, so we want to group up and find groups of 3. So I got 3 2s here. I got 3 m's here. I got 3 n's here as well. So we're going to be able to bring a few things on the outside. The negative 3 is going to stay. The 3 that we weren't able to group up and those 2 m's are going to have to stay as well. But on the outside, we should be able to bring a 2, an m, and an n. We multiply everything together on the outside. We've got negative 6mn, and then cube root of 3m squared left behind inside. And that'll do it. You can find additional examples on simplifying radicals further down the playlist.